Larry, and thanks to the folks for having me down here from upstate New York. I always show this slide at the beginning of the talk about Marcellus and drilling and natural gas, because that's a midwinter, December, cold air breakout over the Northeast that kind of reminds us of why we need natural gas in upstate New York and elsewhere. I should explain that I'm a professor of geology, and I work on the scientific, technical aspects of the Marcellus, not so much the nuts and bolts of gas development, but we do a lot of research locally because we sit on top, basically, of the outcrop belt of the Marcellus. And if I can figure this out. Oops.
Top right on the side. Went down.
There we go. So we're talking about stray gas, and Brian actually mentioned a little bit about the fact that I think he said, oops, that 1 in 4 wells is private water wells in parts of the area that the Chesapeake is working in are found to have pre-drilling methane in them, and that doesn't surprise me at all, because frankly, methane gas is in this region leaking out of deeper rock and rock that's close to the surface. And stray gas is really gas that makes its way into buildings or into water wells in places where it doesn't belong. It can come from natural sources like the bedrock that lies beneath us, but it can also come from poorly designed or faulty gas wells, pipelines, old household lines, and a variety of other sources. And so I put together this talk to really just emphasize that there are a number of sources and just a little bit about the ways that we can tell these sources apart, that is the what we call the fingerprinting of those gases. Here's a handout outside, so I'm going to flip through these slides pretty quickly. The handout really covers most of the nuts and bolts about this. This diagram is just to show that natural gas comes from a whole range of sources in the earth, from very deep, way down in many, many kilometers, many, many miles below the earth's surface, to very shallow gas that can be produced in swamps and in landfills and in manure piles and any place where what we call organic material exists. This is a diagram from the Pittsburgh Geological Society, which I've modified just a little bit to show that you can have gas which comes in from a variety of sources into via water wells, which is a common occurrence, where deep water wells in particular that enter fractured bedrock are capable of allowing gas to enter either in dissolved form or as bubbles into a household water system. That's one of the commonest ways. That gas can result from leakage from an oil or gas well, and just traveling up along naturally fractured rock into basements and so on is a common source. And when you talk about stray gas, it's really just natural gas, and it's important to remember that natural gas consists of mostly methane, and depending upon where you are, some of the other hydrocarbon gases like ethane, propane, and butane. And this is an important criteria for sourcing gas, is the ratios of methane to those what we call heavier or wetter hydrocarbon gases. And basically down at the bottom there I say that there are two broadly defined sources. One is what we call deep gas or thermogenic. It is more likely to be wet, that is, contain heavier hydrocarbon gases, versus what we call biogenic or shallow gas, which is produced biologically and generally consists almost entirely of methane. We also use something called the carbon isotope signatures and the hydrogen isotope signatures of methane from those gases to try to fingerprint their source. This is a complicated diagram. if you run into this problem and you end up having analytical work done, as Brian suggests, particularly with interpreting the results from stray gas analyses, it requires the advice of an expert generally, or a lot of time really reading up on the literature behind this. And in the handout, I've got some suggested sources that are available online that you can look at. But basically, we use what we call gas wetness, which is over on the far left side. That's one axis on this chart. The other axis is an isotope signature of the carbon in the natural gas. That allows us to determine different sources of natural gas. So this is a kind of a fingerprinting operation. But it is not foolproof. And therefore, it's often pretty difficult to exactly fingerprint the source of gas that you've got in a water well. But these techniques do a pretty good job with it. This is another way of displaying another kind of information about natural gas, and that's the hydrogen isotope ratio, which is over on the left. Along the bottom is the carbon isotope ratio, and that shows us the difference between what we call microbial or biogenic gas and deep or thermogenic gas, which is up on the top right. But you can produce some of these same effects by interaction of the gases. So bottom line, the whole fingerprinting, while it's very helpful, does not tell an absolute story. I live up in Hamilton, New York, which is in central New York. And the red there is the Marcellus Shale outcrop belt in New York State, and swings around down into the Pennsylvania border. Actually, New Jersey, New York, Pennsylvania border area. And so we have actually the Marcellus there right at the surface, and just as you go a bit to the south, the Marcellus dips under Younger Rock, and so we have an area where we can actually study the Marcellus right at the surface and then in the shallow subsurface. And we actually have natural gas development in the area, not in the Marcellus, but in a deeper sandstone formation called the Herkimer. And so we have natural gas wells in the area. They're not developed in the Marcellus because the Marcellus, it won't be here because it's really quite shallow. But in the village area, or the area around Hamilton Village, we have some interesting occurrences of stray gas. And in places in outcrop, you can actually see the patterns where natural gas moved up along fractured bedrock in outcrop. We have natural gas seeps, and I'm going to show you a water well, the flaring of gas at a faucet in a water well, where we know it has nothing to do with natural gas wells. It's 5 miles from the nearest natural gas well, yet we have a natural gas seep or a natural gas, stray gas occurrence in household plumbing. Just a diagram which basically shows you the rock layers as they dip to the south. And in the Marcellus, the gas seeps up from below naturally as it's trying to escape from the earth. And as it seeps up, it encounters fractures, and it travels along that fractured bedrock into eventually to the surface. And so we have areas of natural gas seeps, and these are easy to find when the gas bubbles up through stream water, for example. And I've shown on this diagram a guy I work with actually at Colgate, William Peck. His family's water well is drilled into bedrock in a unit that overlies the main gas-producing unit in the Marcellus. And so here's some of this fractured bedrock where we can actually track using geochemical techniques the path of natural gases that moved up through natural fractures. And these are now exposed in road cuttings, and we can actually map out the fracture systems and see where the gas moved up. But here's the William Peck water well, and I'm not sure whether I can make this work on here. I may need to go over to the computer. If you could just put the cursor on there and hit that. Hit the middle of the image, not the. We don't want the YouTube site actually. Just hit the image. It should go. There's William turning on his faucet, lighting, and there it goes. And so when you see the movie Gasland, of course, there are hundreds of these, well, not hundreds, but dozens of these images shown. The point we were making here